Okay, in this video we are talking about transformations of quadratics in vertex form. So the word transformations just means how is the parent function moved up, down, left, or right? How is it stretched or made any wider? And then is it flipped upside down or is it right side up? So there are three parameters that tell us those movements of the parent function of a quadratic. So the first parameter is the a value. That's the number that's in front of the parentheses when you have a quadratic in vertex form. Now this is called vertex form because the vertex, or the mountaintop or the valley, the max or the min, is the point h. K. So when your quadratic equation is in this form, the vertex is h, k. So starting with the a value, whatever number the a is, it can be a negative number. So if the a value is negative, so if it's a negative number, then the graph is flipped upside down. Then the number itself, regardless of the positive or negative, the number can either be bigger than 1 or it can be less than 1. So if a is bigger than 1, then it has been stretched. And when I say stretched, you can either be stretched vertically, so it's made skinnier, or it can be stretched horizontally and made wider. So if a is bigger than 1, it's been stretched vertically. In other words, that means it is more narrow. Then if the a value is less than 1, or if it's a decimal number between 0 and 1, and that means that the graph has gotten wider. Next, we're going to talk about the h value. So the h value is a little bit tricky because in the vertex form of a quadratic, the x minus is part of that form. So when you see x minus a number, that means you're actually moving to the right, which is a little bit counterintuitive. But if this said, for example, x minus 3, right, so if in the parentheses this said x minus 3, this would actually mean you've moved right 3. Whereas if it said x plus 3, this actually tells you that it's moved left 3. So it's kind of the opposite of what you would think for the h value. So if it says x minus h, then you have moved right. And if it says x plus h, you've moved left. So at this point, I want you to notice that the vertex is hk. So for example, if that said x minus 3, then 3 is the h, not minus 3. Notice how x minus, I don't have that highlighted in the vertex form. So if that said x minus 3 plus 4, then 3, 4 is your vertex. If it said x plus 3 plus 4, then negative 3, 4 would be your vertex. So when it comes to writing the vertex, the x value in that point is the opposite sign of what is in the parentheses. Finally, we have the k value, which is much more straightforward. It's pretty simple. If you have a positive k, that means you've moved up. And if you have a negative k, that means that you've moved down. So remember the parent function of a quadratic. Okay, remember that we talked about it's y equals x squared, and that's all there is to it. So in vertex form, what does this look like? Well, it looks like y equals 1 times x minus 0 squared plus 0, right? Because multiplying by 1 doesn't change anything. Adding or subtracting 0 doesn't change anything. So these two are equivalent to one another. They're the same thing. However, this one is in vertex form. The vertex of the parent function of a quadratic is at 0, 0. It hasn't been moved up or down. It hasn't been moved left or right because those values are 0. And it hasn't been stretched because it's only a multiplication factor of 1. So it hasn't been stretched vertically or horizontally. It's only multiplied by 1. It's not bigger than 1 or less than 1 for an a value. And it points upward because that 1 is a positive. So remember, the points of a quadratic come from the table of a quadratic. So if you have your x values and your y values, so we can pick any x values that we want because we're just on the real number line. We have our x-axis and our y-axis. So I'm going to choose a few negative numbers, I'm going to choose 0, and then a few positive numbers to plug in for x and see what we get for y. So I'm going to choose -2, -1, 0, +1, and +2. That just gives us a good range to look at on both sides of the graph. So if y, the parent function of a quadratic, is equal to the x value squared, then we just square each of these x values. So if we take -2 and square it, that gives us +4. -1 squared is 1. 0 squared is 0. And so on. So we can plot these points and see our parent function. So if x is -2, y is +4. X is -1, y is +1. 0, 0, 1, 1, 2, 4. All right, so we have the point -2, 4, 1, 2, 3, 4. -1, 1. +1, 1, and +2, +4. And remember, this creates our U-shaped parabola. So this is the parent function. Right, so let's say if I give you this example, y equals 2 times x minus 3 squared plus 1. Okay, so let's look at this. From this example, this means that it is stretched, so it's more narrow. This tells us that the graph has been moved right 3, and this tells us the graph has been moved up 1. Right, so the graph from the vertex is going to be moved right 3. So we're going to go from here to the right 3 times. So 1, 2, 3. But we're not staying there. Then we have to go up 1. and that's our new vertex. Now, if this had been a -2, then it would be flipped upside down. But since it's a +2, it's still facing upward. It's just going to be more narrow. So just for the sake of sketching this, and this may not be exact, but you won't be asked to graph the changes. You will just be asked to explain what the changes were. So I'm going to just make this a thinner parabola. So it's a little bit skinnier. So you can see how it still is a quadratic, but the vertex has been moved right 3 and up 1, and it's a little bit skinnier because that a value is bigger than 1.